So, oh man, that wasn't smart, was it? You had to plug the rest of it in. All right, so functions, remember, is a set of ordered pairs, a relation where every x has how many y's? No, no, one and only one, right? So when we find the additive inverse, we're just finding the opposite. And the multiplicative inverse, we're doing the reciprocal, right? Let's just review stuff for us. Then we can also find and apply inverses to relations and functions. It says to graph the inverse relation, you can reflect each point across the y equals x line. That means if x is 1, what's y? 1, right? If x is negative 3, what's y? 3, okay? So if we have our, our x-axis and our y-axis, this line goes like this, straight through, like cuts it in half, like at a 45-degree angle. Okay? That's the y equals x line. And that is, it says this is equivalent to switching the x and y values in each ordered pair of the relation. Again, just a quick review. A relation is a set of ordered pairs. A function is a relation in which each x value has one and only one y value paired with it. The x values we call the domain. The y values we call the range. Remember all this stuff? Okay. We had a little test to tell if we looked at a graph if it was a function or not. It went this way. The vertical line test. Remember that? All right, so just kind of revisiting function stuff. I think that's it for this slide. So here's a relation. Here's a 4 ordered pair, 0, 2, 1, 5, 5, 6, 8, 9. And then if you switch the x and y values, then we have 2, 0, 5, 1, 6, 5, and 9, 8. Okay, just flip-flop it. Okay, they would be inverses of each other. And they have a picture of it on the next slide. Okay, so the blue one was the first one. The 0, 2, the 1, 5. Well, it's kind of off there. 1, 5, it should be. Let's see if I can fix it. No. This one? No, never mind. Anyway, the dashed line there, that green one, is that y equals x line. If you look at the blue one was the first relation, and the red one was when you switched them. You can see that if I folded on that green dashed line, they would line up with each other, right? They're reflections of each other. Oh, I got kids who need to take a quiz, don't I? Yeah, sorry. So basically, all we're going to do today, when we have a function and we want to find its inverse, is switch the x and the y and solve for the y. Did I get everybody that needed to? Make sure your phones stay in here, please. Make sure you guys stay separated. All right, sorry for that. So it kind of, and here's this highlighted f with the negative 1 exponent. That means f inverse, or the inverse function. All right, so if our function is f of x, our inverse function is f to the negative 1 of x. Okay, so if I put 3 in that function x plus 6, I get 9. The input's 3, the output's 9. If they're inverses, when I put 9 in the inverse, I should get the output 3. It just flip-flop. Okay, so basically all we're going to do is this. Okay, think of it as y equals x plus 6, all right? And to find its inverse, we're just going to flip those. We're going to put the x where the y was, and the y where the x was, and then we're going to solve for y. So all we have to do is what to get y by itself? Right here, this one on the right. Subtract 6, which is what's going on right there, right? Or you can write f inverse of x. So that's basically all we're doing today. Is that right there? We're going to get a function, f of x equals x plus 6. Think of it as y equals x plus 6. Switch the x and y and get y by itself. That's the procedure for today, to find the inverse of a function. Okay? So let's practice a few. All right? So here's one. So we're thinking of this as y equals x minus a half. So to find the inverse, we're going to go x equals y minus 1/2. And then solve for y. What am I going to do to solve for y, Fred? Subtract 1. Okay, add the 1/2, right. And then we're done. So when it's addition or subtraction, it's really easy. If that's the only thing we're doing. It's going to get a little more complicated in a minute. But not bad. So that's our inverse function. Pretty easy, right? Simple? So far, so good? I think that's it for that. Oh, there we go. You could write it f inverse if you want. But y equals is okay for me. All right, so this one, again, we're thinking it as y equals x over 3. We're going to change it to what? Good. X equals y over 3. How do I move the 3 over? Multiply, right? So we get 3x equals y. That's our inverse function. Good boy. Okay. Let's go over a couple more where you got a little bit more work to do. And then I'll give you your homework. So, again, we're thinking of this as y equals, I think that's what they did too. Yeah. Okay, so what am I going to do now? Switch them. That's what they did. What's the first step to get y by itself? Add the 5, right? So we're going to have x plus 5. And that negative sign kind of got moved in there, but it's still negative. Let's just do this. It's still negative 1/2 y, right? So how do I move that negative 1/2 over? You can divide by negative 1/2, but what's easier? Yeah, multiply by negative 2, the reciprocal, right? So I would multiply both sides, by negative 2 over 1, or just negative 2, okay? And that's what they do next. Okay, but then they move the y to the left, so they just kind of switch sides. And you can leave it like that, that's fine. You don't have to distribute the 2. So we had a couple steps that time. That's pretty easy also, right? Okay. The ones that don't give you trouble are one like this next one. And then they flip-flopped it again here. Okay, there it is. Let's just get rid of that. All right. Now, this part on the right after the comma, what's that telling you? No. No. X cannot be 0. And why is that? Yeah, but why is it? Look at the problem. It'll make the denominator what? 0. Are we allowed to have 0 in the denominator? We call those restrictions. Okay? So on these, if you have a variable in the denominator, when you're done, which you probably will, then you're gonna have to write what the restriction is. What is X not allowed to equal, okay? So there's a little extra part at the end. Now, remember, we're thinking this is Y equals that, right? So now we're gonna rewrite it as X equals 2Y minus 1 over Y. All right, there's two X's, so they both become Y. There's one Y, it became X. We good so far?
Yes.
Miss Doherty. How am I going to move that Y out of the bottom? Right. So I'm going to multiply Y to both sides. So now on the left, I have XY. And on the right, I have 2Y minus 1. Again, what's the goal to finish this up? To get Y by itself, right?
Yes.
Now what you're going to say, Ryan?
Maybe.
We all know what the goal is, right? Mm-hmm. Now I've got a Y on each side, so what should I do first?
Find the Y.
Combine them, right? Get them on one side. So how do I move the 2Y over? Subtract it, right? We're taking 2 and the Y. We're not just getting rid of the 2, we're getting rid of the 2Y, the whole thing. So we're subtracting it, right? Are these like terms? Not really, because I don't know what X is, right? So I just write XY minus 2Y equals negative 1. This is the point where we get stuck. All right, so pay attention. Okay. Again, the goal is to get Y by itself. We want it to be Y equals, but we got 2 Y's. Okay, when this situation happens, think of Y as the GCF. All right, because it's in both, right? Scott, come back to us. Mm-hmm. So I pull the Y out front. What's left in the parentheses then? If I'm factoring X minus 2, right? So we went from 2 Y's. If we factor out the Y like a GCF, we're down to 1 Y. That means Y times X minus 2, right? So how do I move the X minus 2 over to get Y by itself? Now we divide by that, X minus 2. So that's the part that kind of gives us problems. When we see we have two terms with a Y in it and we have to get Y by itself. Factor out the Y like a GCF and then divide whatever's in the parentheses over to the other side and then you have Y by itself. Okay, so we got Y equals negative 1 over X minus 2. Or again, you can write it as F inverse if you want. Either way. But what makes that denominator 0? What value of X makes this equal to 0? 2. So that's the restriction. X is not allowed to equal 2. Okay? So that's the type that might give you a little bit of issues. The rest of it should be pretty easy. That's all we're doing today. Finding inverses. Switching X and Y, solve for Y. Okay? All right. You've got plenty of time to do your homework. Thanks for paying attention.